Imagine you are standing in front of a haystack, a massive, towering haystack. And your job, your only job, is to find a needle.
The classic problem, the ultimate tedious task, right? The definition of a bad day at work.
Wait, it gets worse.
Of course it does.
Because this isn't a normal needle. This needle is a shapeshifter. Sometimes it looks like a standard sewing needle.
Okay.
Sometimes it looks like a bent pin. Sometimes it's just a piece of straw that looks like a needle if you squint at it just right. And the haystack, it's not hay. It's millions of lines of code.
That sounds like a nightmare. But, I mean, you've just described the daily reality for anyone working with data, or, more importantly for us, anyone building a compiler.
Exactly. And that is the nightmare we are waking up from today.
We are back with another deep dive, and today we're looking at the superpower that solves this whole haystack problem. We're talking about the Class 7 notes on regular expressions, or, regex.
It really is a superpower. And if you remember our last deep dive, we talked about the machinery, the finite automata, the scanners. Those are the engines.
But Regex is the fuel. It's the specific language we use to tell that machine exactly what to hunt for.
So let's set the scene. We've got the Class 7 notes on the desk, and we're looking at the Spring 2026 syllabus for context. We are officially in week 3.
The honeymoon phase of the semester is definitely over.
Definitely over. We are moving past the abstract theory of what is a scanner and getting our hands dirty with the actual syntax.
Right. The mission for today is to crack the code of Regex. We need to go from just simple word matching, like finding the word cat, to defining these really complex shifting patterns using what are called meta characters.
Meta characters. It sounds like a villain in a comic book. I am meta character. But before we get to the supervillains, let's ground this. We usually talk about this stuff in the context of building a compiler, but the notes point out that Regex is actually, well, it's everywhere.
It is ubiquitous. I mean, if you use a text editor, you're using Regex. If you're on a command line, you're using Regex. Even when you're just trying to find a file on your hard drive and you type .pdf, that's a simplified cousin of what we're doing here.
Right, or when I'm trying to find, where's that web page I designed?
Yeah.
Or where's that paper I wrote? And I can only remember like half the title.
Yep. Regex is usually that invisible engine powering the search. And engine is the key word there. It's not magic. There is a literal program, the Regex engine, running under the hood.
And understanding how that engine thinks is the difference between writing a pattern that works and writing one that, crashes your whole system.
Exactly.
So let's get inside the engine's head. The notes describe its process as working atom by atom. That sounds incredibly slow.
It's incredibly fast in practice, but it's very meticulous. It's hyper-focused. It doesn't read a whole sentence at once like we do. It looks at a single character position at a time.
Let's walk through the example in the notes because I think it visualizes this perfectly. We're searching for the pattern, the capital TH, T, and the text we're searching through is the sentence, thick darkness came.
A bit dramatic, but effective. So the engine starts up. It looks at the first character of the text, the T in thick. It compares it to the first atom of your pattern, the T in...
T matches T, green light.
Exactly. So it advances. The engine moves its little pointer one spot to the right. Next character in the text is H. Next atom in the pattern is H.
Match. It advances again.
Now the third character in the text is I, from thick. But the pattern expects an E from the.
And that's a fail.
And here is the crucial moment. Red light. The mash fails. But the engine is persistent. It doesn't just throw its hands up and quit. It does a backtrack, a reset.
So it doesn't just jump to the next word.
No, and this is so important. It goes back to the text, moves exactly one character forward from where it started the last attempt. So now it's looking at the H in thick, and it starts the whole pattern over.
And it asks, does H match T?
Which fails immediately, of course. Then it resets to the I. Then the C, it just crawls through the text character by character, trying to overlay your pattern until everything lines up.
It's almost like a zipper that keeps getting stuck and having to restart from the next tooth.
That's a great way to picture it. And when the zipper finally closes, when every atom matches in order, it returns what the notes call metadata.
Right. It doesn't just say true or yes. It tells you where, the start index and the length.
Which is vital for a compiler. A compiler doesn't just need to know if there's a variable name. It needs to know, okay, that variable starts at character 45 and ends at 49. That specific chunk is your token.
Okay, so that's the mechanism, the engine. Now let's talk controls, the syntax. The simplest version is what we just did, a literal. You want the, you type the.
Simple but fragile. Because Regex is case sensitive by default. If you search for the with a capital T, you are completely blind to the with a lowercase t.
which is frustrating. In a Google search, you're used to it guessing what you mean. Here you have to be explicit. If I want the or the, I don't want to run two separate searches.
And you don't have to. You just have to be precise, but flexible. This brings us to our first major tool, the character set. You'll see these as the square brackets.
The square brackets. I kind of think of these as a VIP club. If you're on the list inside the brackets, you get in.
That works. A character set defines a single position in the text, but it says, I will accept any one of the characters inside these brackets for this one spot.
So if I write Tida, I'm basically saying, for the first slot, give me a big T-O-R, a little t. I don't care which. But after that, I strictly need an H and then an E.
Precisely. It solves the capitalization problem in one go. But you can do more. Say you need to match any number. You could type, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
You could, but that seems incredibly tedious. And I would definitely miss the 7.
It is tedious. That's why Regex supports ranges. Use a hyphen. 0, 9 tells the engine accept any single digit from 0 to 9.
And you can combine them right. The notes show Azaz.
Yes. That effectively means any letter. Capital A through Z or lowercase a through Z. It's a very common pattern for finding words or identifiers in code.
You can also get creative with these lists. I saw a fun example in the notes. 02468.
The even digit filter. It just shows you can mix and match. You're not limited to standard ranges. If you want to match only vowels, you just write AU.
Okay, what about the inverse? Sometimes it's easier to say what you don't want, like I want anything that is not a number.
This is where the syntax starts to get a little crowded, so you have to pay attention. We use the caret symbol, that little upward arrow way. You place that inside the square brackets right at the start. It becomes a negation operator.
So 09 doesn't mean start with a number.
No, not at all. It means match any single character that is not a digit. It flips the logic of the club. Everyone's allowed in except the people on the list.
It's amazing how one little symbol, that caret, changes everything depending on where it sits.
Context is everything in Regex.
Speaking of symbols, we have to talk about the escaped problem. The notes make a big deal of this. We're using all these symbols, brackets, dots, plus signs to give commands to the engine. But what if I actually want to find a dot, like a period?
This is the most common stumbling block for beginners, I think. If you just type a dot in your pattern, the engine sees a command, a meta character. To tell the engine, no, relax, I literally mean a period, you have to escape it.
With a backslash.
With a backslash.
So them, no backslash means them, followed by something. But them, with a backslash, matches the specific word them, followed by a literal period.
Exactly. The backslash is the do not disturb sign for the engine. It says, treat the next character as just text, not a command.
So let's go back to the dot itself.
Yeah.
The dot. The notes call it our first meta character, the ultimate wildcard.
It is. A lone dot in Regex matches any character. Well, almost any. It usually won't match a new line, but it'll match letters, numbers, symbols, spaces, anything.
So if I search for TT, that's a T or T followed by 2 dots.
Yeah.
What am I actually catching?
You're catching 3-letter strings that start with T. So me, 2, 10, but also ta, T99, TR.
T-space R.
Right. It's powerful, but it's also dangerous because it's so greedy. It just swallows everything.
There is a constraint here, though, that I found interesting. The notes emphasize that the dot must match something. It cannot match nothing.
Yes, that is a critical distinction. A dot is a placeholder that must be filled. If your pattern is the, and you're at the very end of a line with nothing after the E, that match will fail.
It can't match the absence of a character.
Right, it needs matter to consume.
Okay, so we've got atoms, sets, wildcards. That handles the what. Now let's talk about the where, location. The notes introduce anchors.
Anchors are fascinating because unlike a dot or a letter, they don't consume any characters. They're zero width. They just assert a position.
And we see the caret again here.
We do, and this is why context matters so much. If the caret is inside the brackets, E, it means not. But if that caret is at the very start of your pattern, outside any brackets, like the,
it means started line.
It means start of line. So it only matches the D if it's the very first thing on the line.
And its partner is the $sign. That's the end of the line.
Correct. The is looking for a line that ends with the. It's incredibly useful for validating data. Like, if you want to make sure an input box contains only a number, you might use 0, 9, and A.
Start line, 1 digit, end line, nothing else allowed.
Exactly.
Now, this leads us to maybe the most confusing yet useful concept in the whole deck, the word boundary, the B.
B, this is a huge conceptual leap. When you see B, your brain wants to think it's a character, like N for new line or T for tab.
But it isn't.
It's not. It's a ghost.
A ghost. I like that, so it doesn't take up any space.
Essentially, B represents a boundary between a word character, like a letter or number, and a non-word character, like a space or punctuation. It just checks the state of that transition.
Okay, so the notes use the example of finding the word the again. If I just search for the, I find them, breathe, scythe, all this extra noise.
Exactly. You're just finding the substring. But if you wrap it in boundaries, now you're strictly finding the word the standing all by itself.
You're telling the engine, I want a position where a word starts, then THE, then a position where a word ends.
Precisely. This is so useful for finding variable names in code. You find count without accidentally replacing the count inside a count.
That is the classic find and replace disaster that B prevents. Okay, we haven't talked about the pipe, the symbol, the OR operator.
Yes. So the node is another way to solve that capitalization issue. It means match the thing on the left, OR the thing on the right.
But the notes have a big warning label here, a common mistake.
Yeah.
It's about precedence. It seems like the pipe is, I don't know, weak.
Weak is a good way to put it. It has very low precedence. Let's look at the example from the notes. Bimisar, you want to find any of these verbs.
Right. And naturally, you want to use those word boundaries we just learned. So you write, Bisamarab, it looks perfect.
It looks logical, but it is dead wrong because the pipe splits everything. The engine reads that as 4 completely separate options.
Okay, walk us through it. Why is this a trap?
Option 1 is everything to the left of the first pipe, klebi. That means B at the start of a word, but it doesn't check the N, so best matches, behind matches.
Oof. Okay, so we're already catching junk.
Option 2 is just is, no boundaries at all, so thistle matches, history matches.
Option 3 is am, so example matches.
And option 4 is RAR, so hair or Blair will match because it only checks the end boundary.
So you've built a completely leaky bucket. You thought you applied boundaries to the whole group, but you only apply them to the very first and very last options.
Exactly. To fix this, you need grouping parentheses, which the notes hint at. You'd need to write B by Samara B. But the key takeaway for now is be very careful with the scope of that pipe operator.
Got it. Parentheses are like the containment field.
Yeah.
Okay, before we get to the homework, there is a giant red flag in the notes, a slide titled Important Conceptual Issue.
Yes, the stop and listen moment. We've been talking about Regex as a search tool, finding needles in haystacks, and we use it that way to learn the syntax. But, and this is critical, the scanner in a compiler does not search.
Wait, really? I thought that was the whole point. We're finding tokens.
It's a subtle but vital distinction. A search tool, like find in your text editor, skips over text to find a match. It hunts. The scanner you're building in this course, it consumes.
It consumes.
It reads the stream of characters one by one from the beginning. It doesn't look ahead for a match later on. It asks, what is this chunk of text right in front of me right now? Is it an if? Is it a variable, a number?
So it's not scanning the horizon for a pattern. It's identifying the object that's in its hand.
Perfectly put. It emits tokens sequentially. If the text in front of it doesn't match any of your patterns, it doesn't skip it. It throws an error. It says, I don't know what this is.
That's a really helpful shift in mindset. We use the search mindset to test our patterns, but the scanner mindset is about strict sequential consumption.
You have to wear 2 different hats. If you try to write a scanner that searches, you're going to get a very, very broken compiler.
All right, let's get to the nitty-gritty, the practical application. The notes introduce a tool called grep.
A classic, and a great piece of trivia. The name grep comes from an old text editor command, .grep. Global Regular Expression Print.
I love that. It's just an acronym that became a verb. Just grep it.
Exactly. And for those of you who are actually in the course or following along, there are specific instructions here for what you need to do right now.
Right. You need to go to your CS330 individual lab work directory, and then
run git pull.
And this is going to fetch a new directory called Regex Exploration. Inside, there's a program, regex.c.
This is a simple C program the instructor provided. It's your sandbox. You give it a pattern, you give it some text, and it'll highlight the matches for you.
The example they give is a.out whoa, hello world, and it spits out the indices, first 7, 9, and highlights the whoa.
Use it, break it, try that Bimasar trap we just talked about, and see it fail in real time, because you really need to get comfortable with this syntax before you try to build the actual scanner.
Which brings us to the homework, Lab 1.
Lab 1 is due Monday, February 9th. That's week 4. And this lab is all about C regular expressions. It is the direct application of everything we've just discussed.
So this isn't just theory for the sake of theory. This is, can you build the tool?
Exactly. And looking at the syllabus, tomorrow, Friday, is the LLM roundtable.
Right. And this is interesting. The syllabus mentions LLM throttling and 3 modes of engagement. I've got this, vibe coding, and you do it.
Vibe coding sounds fun, but for Lab 1, I really think you need to be in I've got this mode to understand these Regex basics.
The syllabus actually mandates it. You have to complete at least 2 exercises in each lab without any AI assistance. And frankly, with Regex, you need to build that mental muscle.
But why? Can't ChatGPT just write the pattern for me?
It can,
Yeah.
but Regex it's dense. People joke that it's write-only code. If you let an AI write a complex pattern for you, and then your compiler breaks 3 weeks from now because of some edge case, you will look at that string of symbols and have absolutely no idea what it does.
You won't be able to debug your own foundation.
Exactly. You need to own the pattern. You need to be able to look at Bayes plus B and just read it like a sentence.
That's good advice. Build the foundation now, automate it later.
So, to recap, Regex is this powerful syntax for defining text patterns. It works with an engine that crawls atom by atom. We build patterns using literals, character sets, and ranges. We control the logic with negation and pipes, peef, and we pin it all down with anchors like beef and those tricky boundaries B.
That's the toolkit.
So here's a final thought to leave you with. We talked about the engine crawling through text, strictly matching patterns, resetting when it fails. It's very mechanical, very unforgiving. Anchor means strictly start and strictly end. 0 wiggle room.
It is binary. It's either a match or it's not.
But think about the human brain. You get a text message. It has 3 typos. It says CUTMRW.
Yeah.
Your brain doesn't return match failed. Your brain runs a fuzzy regex and says, yeah, I know what that means.
We are giant biological pattern matching engines with incredible error correction built in. We basically autocorrect reality in real time.
Exactly. So the question is, as we build these compilers, how much error correction should we build in? Should our code be these strict sticklers that crash on a missing semicolon? Or should they be able to, vibe with the typos?
That is a dangerous question for a compiler designer. If you guess wrong, you change the entire meaning of the program. But it's where the future of coding might be headed.
Something to mull over as you wrestle with your backslashes in Lab 1. Happy pattern matching.